Hello everyone, this is Ms. Page. In this lesson we are going to talk about how to graph sine and cosine functions using some of the characteristics of the function, amplitude, period, and midline. So first off, we are going to talk about what we mean by the period of a sine function or a cosine function. The parent functions have the same period, so that is something that's nice because it makes it easier to remember. So what we're looking at here is that this graph right here is f of x equals sine of x, and when we talk about one period of the function, we are talking about one cycle of the curve, whether it's sine or cosine. Here it says sine, but it's the same thing for cosine. And the idea is sine and cosine are wave-like curves. They repeat themselves to positive and negative infinity for x. And so we look at this section right here in orange, and it is what we mean by one period. So a period is an interval of your x values, and here we start at an intercept, and then it goes up, hits an intercept, goes down, hits a minimum, that was a maximum there, and then it comes back, and after that it starts to repeat itself to where it'll go from 2 pi, which is an intercept, back to a maximum. So it's going to be doing this part again, and then it curves around and over and over and over again. So from 0 to 2 pi would be one period. Now, it's not only from 0 to 2 pi. I want to point out that we could start, say, at a maximum and end at the next maximum, and the interval here would also be 2 pi radians. We could also start at a minimum, trying to get a different color here, there it goes, and end at the next minimum, and this interval right here would be 2 pi radians. So that's what we're talking about, from a beginning to an end right before it starts to repeat itself. That is the period of the function. So here we are going to add to that then. We've talked about the period of the function. We also wanted to know what is meant by the amplitude and the midline. So the midline is a horizontal line that goes through the function. Here it's shown here as y equals 0, right here. This is our midline. But it specifically goes kind of right through the middle of the function, if you want to think of it that way. But mathematically what it is it's exactly halfway between the location of the maximum and the location of a relative minimum. So here our maximum is at 1, our minimum is at -1, and so halfway between 1 and -1 would be 0. And so our midline runs along y equals 0 because of that. The amplitude of a function is actually the distance from the midline to a maximum or a minimum. So our midline here is our x-axis, which is y equals 0. The distance at the maximum, which is 1 unit, then is also our amplitude. This right here, not really that, because that's not always a 1. This right here, then this distance, which is 1 unit, that is our amplitude. So you could also look at your amplitude is half the distance between a maximum and a minimum. If you go from a maximum to a minimum, then it's a distance of 2 units, and half of that would be 1. So that is another way of looking at amplitude. All right, so here we are going to be looking at, given a graph, first off, we're going to practice finding the amplitude, the period, and the midline of the function. It doesn't tell us, this says it's a graph of a sine curve. All right. We would do the same thing if we had the graph of a cosine curve. So what we want to do first, really probably the easiest thing, is to find the midline first. And we would do that by finding a maximum and a minimum. So here's a maximum. It's at a y value of 4. And here's a minimum. It's at a y value of -2, given this particular scale. And so from 4 to -2 is 6 units. Half of 6 is 3. So I can count down 3 from the y value of 4, which is my maximum, or up 3 units from my -2. Either way, I end up at a y value of 1. 1 plus 3 is 4. 1 minus 3 is -2, which means my midline is going to run horizontally through 1, making it the equation y equals 1. Don't ever say the midline is just a number 1, because it's a line, it needs that y equals. All right, so now next thing we're going to take a look at is the amplitude. So our amplitude is directly related to our midline in that we really need to know where the midline is in order to do the amplitude one way, or we could do the math using the maximum and the minimum. So for our amplitude, so one way it would be to measure from our midline to a maximum, which would be 3 units, or from our midline to a minimum, which would be 3 units. So our amplitude is 3. Another way would be to do the math and take the maximum y value, which is 4, subtract the minimum y value of -2, and then divide that by 2 to get half of it. And that is, of course, 6 divided by 2, which is also 3. So you could get your midline that way. Third thing here we want is the period. So it depends on how the graph looks, what's going to be easiest, the easiest way to find the period of the function. If you can find really nice points to work with, then do that. For example, I have got here if I want to start at like a point that's on like a -2 pi or at 0 or at 2 pi, I'm not going to get one of my key points. It's not an intercept, it's not a maximum, it's not a minimum, but it's okay if I start there. But I have to be able to figure out where I end. So if I follow my curve, it ends right there, and that's the point that it starts to repeat itself. So I'm going from 0 to 4 pi before it starts to repeat itself. It's on its way up with this little piece here again. And so the period is 4 pi. I could also start at a maximum, which is here, and then I'd end at the next maximum. The problem with that is that, it's not at a nice given value. So I'd have to realize, okay, well, that's 2, 4, 6, 8 squares. 8 squares would be equal to 2 pi plus 2 pi, which is 4 pi. Or you have to do the math and go and know that this right here would be, this is -3 pi in the middle, so this would be -2.5 pi. This would be 1.5 pi, that kind of a thing, and do the math that way. So different ways to look at the period, but you've got to find a starting place, a nice point to start with, and then be able to figure out at the point where it ends that first cycle, which is where right before it starts to repeat itself. So the period in this case would be 4 pi. And that is units of radians. We don't always necessarily have to write the units. I just wanted to mention that. All right, here is a practice problem. Pause the video, give this one a try to find amplitude, period, and midline. All right, let's take a look. So, how did you do? Here's our results. So midline is y equals -3. The maximum here is at -1. Minimum is at -5, and that's 4 units. So halfway would be 2 units from either of those, which puts you here at -3. That's your midline, y equals -3. So then the distance in units from that midline to a maximum, or from that midline to a minimum would be your amplitude, and that's 2 units. So that's what we see here. Also with the math, you can take your maximum value minus your minimum value and divide that by 2, and that also gives you 2 units for an amplitude. And then the period on this one is 2 pi radians. You can start at 0 and then figure out where it ends right before it starts to repeat, which would be 2 pi. 2 pi minus 0 is 2 pi. Or if you started at, say, a maximum, you'd end at the next maximum. That right there would be 4 squares, which would be 2 pi radians. You can go from a minimum to a minimum, 4 squares, which would be 2 pi radians, so on and so forth. Here's another practice problem for you to try. Pause the video. All right, let's take a look at this one. So, how did you do? Here's the results up here. So the midline here is y equals 6. We have a maximum y value of 9 and a minimum y value of 3. So you can do 9 minus 3 divided by 2, which is 6 divided by 2, which is 3. Or you can realize, okay, halfway between those two values, which would be 3 units up or 3 units down, would be the midline. And that goes through y equals 6. So that's our midline, y equals 6. And then go up from your midline to a maximum, or from your midline down to a minimum and count the number of units, which would be 3 units that way. The period in this case, hopefully you came up with 3 pi radians. This one, this is an intercept point. And then I'd have to go past this intercept point because it's not starting to repeat itself. So when I started an intercept, I have to actually go 2 intercepts to get to the point where it repeats. So 1 up, 1 down, and then it starts up again, which is a repeating. So it goes from here to here. And this is 3 pi radians, and that's 0. So this right here is the period of the function, 3 pi radians. All right, so that is going to end part 1, and this will correspond to the first assignment. So you can work on that worksheet and have a great day.